Hi everyone. So first, thanks Dan and Kevin for organizing this event in the CICI community, and really great to see everyone again in today's meeting. So we'll first briefly share our proposed project on data provenance framework for medical machine learning research, and also briefly discuss about our data requirements and also open sourcing tools. So first, I will give a brief overview about our proposed project. As is shown on the first figure, we propose the development of a provenance framework designed to detect, track, and manage medical datasets used in training medical image models or fine-tuning medical large language models. So this framework will ensure dataset transparency, compliance with privacy regulations, and the ability to remove compromised or request to be deleted data from trained model efficiently without returning. So as demonstrated in this figure, our research has three key thrusts. The first thrust is automated inferences of public machine learning model that were trained on corrupted or sensitive data sets. The second thrust is efficient logging of data sets and machine learning models usage in medical research workflow. And the third thrust is efficient machine learning schemes to remove the compromised data sets or sensitive data points without retraining. So as for the benefits to scientific cyber infrastructure, we provide data provenance and reproducibility for medical AI. And we also provide advancements in integrity and trust in shared resources, especially for medical cyber infrastructures. Next, for the risks versus potential for advances, so the risks are the challenges to accurately and efficiently trace medical AI data, and also the challenges to enable data transparency and support compliance, such as including the ability to honor data withdrawal requests, and maintain transparent audit trails for funding agencies and institutional review boards, and also research ethics committees. So the advances also include like enhanced medical applications and bolster patient confidence with trustworthy machine learning AI. So next, I will go through the need for integrity, provenance, and authenticity. So for our goals for the project, we have three goals: integrity, provenance, and authenticity. For integrity, we want to detect public models trained on the corrupted data. For provenance, we built standardized, efficient, reproducible dataset model tracking. And for the authenticity is that we would remove patient or corrupted data from models effectively without retraining. And for our approach for achieving the IPA in the AI datasets, we propose membership inference-based method for medical AI data provenance and program analysis method for data provenance in medical workflow, as well as machine learning schemes for multimodal medical data. And next, I will go to the evaluation and demonstrating IPA. Here we define metrics for success include accuracy of data provenance, efficiency of data provenance, and privacy guarantee of machine learning. We actually, to have brought more impact of the project, we will release the tools for medical AI provenance publicly through GitHub. We'll also share some of the public medical data sets that already removed PIIs and sensitive information with like potentially with collaboration here for the two possible options. And also, we plan to host workshops for better outreach to the medical community in general about our data provenance framework. The program details include like this is 3-year project starting on November 2025, and it's led by University of California, Los Angeles, and with University of Colorado Springs. So next, I will go to our dataset requirements. So first, we'll definitely share our open source tools with well-documented Python scripts for querying, downloading the pre-processing. And also we will set metadata standards, include standardized metadata, such as study criteria, disease type, and patient demographics. So in our research, we also use some public data sets, such as the National Lung Screening Trail. For this, we can have GitHub or cloud-based data storage, all like in collaboration with more advanced access control. So this will be publicly available with the tools shown above. And for the private data set, we definitely will also use private data set with our medical collaborator, Chen. But for this data set, our storage will be institutional storage. Basically, we'll actually work on the medical cyber infrastructure here at UCLA and UCCS. Um, and um, and uh, it might be unlikely to share this private medical data set because they are highly sensitive. But anyway, we'll release our tools and share the public data set we use in the research. We'll be happy to discuss about sharing data more on this front. Thanks, everyone. So that's a brief overview, and we'll be happy to take questions, and I'll be happy to see if Yan and Aichi has anything to add.
All right. Sounds great. So a couple thoughts here, right? So this is and this will be applicable to sort of all the projects, right? So there's a mix of software tools, public data sets and just internal data sets, right? I think from the data set side, those public data sets, that's great to have them out in one of the platforms, OSDF, NDP, that kind of thing.
Mhm.
I think there's also some interesting questions here about, on twofold. I'm thinking of this on twofold. One is, all the cool stuff about integrity and provenance and authenticity, right? What, if anything, needs to be integrated into platforms like an OSDF or an NDP? Because that will be kind of fundamental. So I think there's sort of a, you know, what can this tell us, NSF and the other platforms about what we should put in there? The other thing is I really like that this is looking at the medical data, which brings in its own set of stringent requirements, right? I mean, this is not
Right.
of course, all the private data we need to keep private, but here there are pretty severe consequences and legal ramifications if you don't
Mhm.
if that data is not right. So I where does the medical, do you know where the medical community goes to, how does the medical community get data set access? Is there a
So
standard way or yeah?
yeah, actually might be able to explain more, but given the public data set we have been looking at, most of them they remove all the like sensitive PI data and other data that might be sensitive. And they also have like lots of IRB requirements regarding using downloading, who will be able to download and use the data. So actually, if you want to add anything regarding public access to medical data.
Okay, thank you.
Yeah.
This is IT Chen, Dr. Chen from UCLA Radiology Department. I have been working with medical data for about 20 years and have my research is really heavily built up on data and longitudinal follow-up data sets. And in the old days, we don't have so many issues or data sharing. People don't want to share from in the medical field, it's a very conservative um, uh, society or environment or group of people. And you can actually, if you say it, a little bit paranoid too, because the technology is so advanced and compared to the medicines that we were very behind. So how do we usually share data from the medical researchers' point of view is that typically we start a project already beginning with the data sharing. So it's very in the older days, it's not very common to see someone want to share some already exist data sets. Okay, so usually it's already a collective sponsorship, and the data already shared based on the work. So these days, there are more and more sharing requirements, including NIH also asks us to do that, and so we are actually growing, trying to adapt to this new field, new requirements. And I'm really happy to be in this project, because I actually can learn more about things that we don't know we can do. We can be safely also share or study and with other people's help. So I think this I can these days people don't want to share at this moment, but I think this need to change. And by changing from knowing where is the science, where is the technology can help the protection, for example, this group of the scientists, and by that I think a medical field will be more comfortable and started to incorporate more compliable regulation, or maybe some rules to allow this to be more freely researched.
Excellent. All right. Well, this is, and then I think there's stuff we can take offline, but just a quick question for the OSDF and NDP teams. Are you currently as much medical data in the system, or is this sort of a new? Will medical data be a little bit branching out for you guys, or is that something you guys are already incorporating in?
I think as Chi-Chin said, that it depends a lot on whether the medical data is restricted or not, right? So if it's the NLST data set that was referenced, that's if it's been de-identified and not considered restricted data, even though we don't have many examples like that, it's relatively similar to particle physics for all I care at some level. But then for restricted data, that's a whole different ballgame, and that's one where I think at this point in time we're not really pushing on the restricted data side, because then particularly the data distribution and delivery gets tripped up quite a bit more in the regulatory pieces more than the technical. So it really comes down to whether it's been de-identified and kind of blessed by the IRB as not having particular restrictions or being public.
Yeah, one thing I want to add is, in the past, only the identification will be enough, but because of all these AI grade algorithm, you can actually find people through a various different algorithms. So that actually imposed another layer of concern from the medical society. So something that this project, the Provenance project, is trying to address, and I'm working with my great co-PIs. They are smart on this, and I'm very grateful.
Yeah, that's been fun over several generations of these things. De-identified is not a static property, right? What is de-identified 15 years ago may no longer be that way. So that's where some of this I think it's really really interesting is that these are evolving as time goes on.
Yeah, Dan, I I feel that while we think technology, I feel that we are missing in terms of organizational. Anytime we deal with restricted data, who approves whatever is being done within the project, and whether it's medical or non-medical or restricted by other reasons, who checks what's going on and says, yes, this is good enough to deal with the restriction on the data. And something which is related to it, which goes into the medical, and if you look at HIPAA, is that a lot of it has to do with auditing. It is not as much making sure that you cannot access it, but making sure that if you access it, we will find you and punish you. And I think that throughout our infrastructure, we are not in great shape when it comes to auditing.
Yeah, no, I think a lot of cool stuff here. So I think this is great. We got a lot more to follow up on offline, but thanks so much. I think this would be really exciting. All right, one last quick comment, and then we'll switch over to Scripps. So actually, Scripps AI, if you could pull up the slide while I give one last comment on this. One motivating factor in our developing of the IPAA track on this was a close friend of mine, is the director of the Pediatric Epilepsy Research Center. And they ended up with some data that was sent to them by a parent via Gmail, right? And they had a lot of interesting questions about provenance, authenticity, HIPAA regulations via all that, and it was so I'm very interested in this topic, and this is I think there's some real exciting things we can do here. So great job. All right, but let's switch over
Thank
to.
you so much. Thank you so much, Dan. And we really hope to bring the data provenance to also to a larger community. Like you're also talking about potentially collaboration with WAD and NDP for some data provenance work. So that's really resonate with us as well. Yeah, thank you.
Excellent. Sounds good.
Thanks, Sunbrain and Miro, and for your comments as well. Really appreciate the suggestions.